Before humans could see a single bacterium, before anyone knew what a cell was, someone in ancient Assyria was already grinding rock crystal into a lens. This is the 400-year story of how we learned to see the invisible. From a polished crystal disk to instruments that can image a single atom, the microscope's history is really the history of human curiosity refusing to stop at the edge of what the naked eye can see. This is the Nimrud lens, a piece of polished rock crystal unearthed in an Assyrian palace in 1850. Dated to around 750 BCE, it may have been used to start fires or aid eyesight, nearly 3,000 years before anyone called it optics. That makes this little disk of crystal roughly 27 centuries old, one of the earliest known ground lenses in human history, and a full 2.5 millennia before anyone built an actual microscope. The real leap came around 1590 in the Dutch town of Middelburg. Spectacle makers Hans and Zacharias Janssen found that stacking two lenses in a tube magnified far more than either lens alone. The first compound microscope. That's the core trick behind almost every optical microscope since. A compound microscope uses two lens systems in sequence, an objective lens near the specimen and an eyepiece near your eye, multiplying their magnifications together. Just 2 decades later, Galileo Galilei, already famous for pointing his telescope at the stars, flipped the same design around to look at insects up close. He called it his occhiolino, the little eye. It was the first time a scientist of Galileo's stature took the miniature world as seriously as he took the night sky. In 1665, English scientist Robert Hooke published Micrographia, the first great work of microscopic illustration. Looking at a sliver of cork, he saw tiny walled compartments and named them cells, after the small rooms monks lived in. Micrographia stunned the public. Fleas, feathers, and frost rendered in engravings so detailed that Samuel Pepys called it the most ingenious book he had ever read. While Hooke stacked lenses, a Dutch cloth merchant named Antonie van Leeuwenhoek went the opposite way. He hand-ground tiny, near-spherical single lenses of astonishing power and turned them on pond water and his own dental plaque. What he saw made him the first human being to witness a hidden universe. Bacteria in his own mouth, protozoa swimming in pond water, red blood cells, and even sperm cells. He called them all animalcules. 3 men, 3 decades, 3 ways of looking. Galileo adapting a telescope, Hooke stacking lenses to reveal the cell, and Leeuwenhoek grinding a single lens sharp enough to find bacteria. Between them, they founded microscopy as a science. Quick pause. If this breakdown is helping you, take a second to hit like and subscribe. It genuinely takes a lot of effort to make videos like this, and your support keeps them coming. Zoom out and the timeline is remarkable. From a curious lens in ancient Assyria, to Janssen's first compound design, to Galileo, Hooke, and Leeuwenhoek all working within a single 70-year window. The floodgates had opened. For over a century after Leeuwenhoek, microscopes were plagued by colored halos blurring fine detail, chromatic aberration. This 1857 instrument represents the fix, achromatic lenses that combine different glass types to cancel out that distortion. The breakthrough behind that fix came in 1830, from an unlikely source. Joseph Jackson Lister, a wine merchant and amateur scientist, worked out how to combine lenses so chromatic blur simply disappeared. For decades later, physicist Ernst Abbe partnered with instrument maker Carl Zeiss and went further. He worked out the actual mathematics of how light behaves inside a microscope, turning instrument building from guesswork into precision science. Abbe's 1873 formula was profound. It proved that light itself has a wavelength, and that wavelength sets a hard mathematical ceiling on how small a detail any light microscope can ever resolve, no matter how good the glass. In practice, that limit caps a light microscope at around 200 nanometers of resolution and roughly 1,500 times magnification. Good enough to see a cell, but nowhere near good enough to see a virus. The light barrier stood unbroken until 1931, when German engineers Ernst Ruska and Max Knoll had a radical idea. Replace light with a beam of electrons whose wavelength is thousands of times shorter, and focus it with magnetic coils instead of glass. The difference in resolving power is staggering. A light microscope tops out around 200 nanometers, while an electron microscope can resolve details less than a single nanometer wide, sharp enough to see the shape of an individual protein. Ruska won the Nobel Prize in Physics for the invention in 1986, 55 years after he built it. Today's descendants of his machine, like this modern transmission electron microscope, image viruses, proteins, and the fine architecture of the cell as a matter of routine. Put the two ends of this story side by side, Janssen's first compound microscope in 1590 magnified maybe 9 times. Today's cryo-electron microscopes can resolve individual atoms. A leap from seeing a flea's leg to watching a single molecule fold. From a polished crystal in an Assyrian palace to a machine that can watch a single molecule move, the microscope's 400-year story is really the story of how far curiosity can see when it refuses to stop looking. Here are the key references and sources for this video. Thanks so much for watching. If this helped, like the video and subscribe for more clear, simple explainers, and I'll see you in the next one.